long before letters replaced unknowns, long before neat symbols lined blackboards. Algebra existed as something much closer to a story than a formula. It was spoken, it was written in sentences. It unfolded step by step, like a careful argument, told aloud. There was a time when mathematics had no shorthand, no compressed language of signs. Every idea had to be explained fully, patiently, and clearly. And yet, in that world without symbols, one of the most powerful branches of mathematics was born. This is the story of how algebra began, not as symbols, but as language. Imagine trying to solve a problem where something is missing, but you are not allowed to name that missing thing with a letter. You must describe it. You must reason about it using words alone. You must explain why each step is valid, not just write it down. This was not a weakness. It was the foundation in the early centuries of the medieval world. Knowledge was scattered. Ancient Greek texts survived in fragments. Indian mathematics carried deep insights into numbers and calculation. Persian and Babylonian traditions preserved methods of measurement and astronomy. Much of this knowledge was in danger of being lost. Then something extraordinary happened. In the heart of the Islamic world, scholars decided not merely to protect knowledge, but to collect it, translate it, and build upon it. Cities like Baghdad became places where ideas met, where texts were not treated as sacred relics, but as starting points for new thought. Mathematics was not separated from daily life. It was used to divide land, settle inheritance, calculate trade, and design buildings. In this world, problems mattered because they affected real people. A family needed to divide property fairly. A merchant needed to calculate profit without error. A builder needed to measure space accurately. These were not abstract puzzles. They were questions of justice, economy, and order. And questions like these often shared one thing in common. Something was unknown, not mysterious, not magical, simply unknown. How do you reason about something you do not yet know? This question stood quietly at the center of algebra's birth. Among the scholars working in this intellectual atmosphere was a man whose name would echo through history, even if his face never would. He was methodical, careful, and deeply practical in his thinking. He was not trying to impress. He was trying to explain. His work was not written for philosophers alone. It was written for judges, merchants, and ordinary people who needed reliable methods. He wrote a book describing how to solve problems by restoring what is missing and balancing what is unequal. These ideas were not presented as tricks or shortcuts. They were presented as logical steps that anyone could follow. Each problem was told like a story. First, the situation was described. Then the unknown quantity was identified in words. Then, each step was explained carefully, showing how balance was preserved. Nothing was assumed. Nothing was hidden behind symbols. This was algebra as reasoning, not notation. What made this approach revolutionary was not its complexity, but its generality. Instead of solving one specific problem, the method applied to many problems at once. The same reasoning worked regardless of the particular numbers involved. For the first time, people were learning how to solve any problem of a certain kind. This was abstraction in its purest form. Unknown quantities were treated as real things that could be compared, adjusted, and reasoned about, even before their actual value was found. This shift changed mathematics forever. Before this, mathematics often dealt with concrete quantities, lengths you could draw, numbers you could count, shapes you could see. Now, mathematics was learning to deal with absence, with what was not yet known, and to do so logically. This new way of thinking spread, quietly but steadily. Scholars copied the methods, teachers explained them, courts relied on them, traders trusted them. Centuries later, these ideas traveled again, this time into Europe, where they would slowly be transformed. Words would eventually shrink into symbols. Sentences would become signs. Letters would replace descriptions. But the logic remained the same. Symbols did not create algebra. They only shortened it at its heart. Algebra has always been about restoring balance and reasoning through the unknown. It is a way of thinking, not a collection of marks on a page. And that way of thinking was born in a world that believed knowledge should be explained, not hidden. Before algebra was written in symbols, it was told as a story, and perhaps that is why it still works. As this new way of reasoning spread, it did not move through battle or conquest. It moved quietly, carried by teachers, judges, merchants, and scholars who found that it worked. A method that could resolve disputes fairly had value, a way of thinking that could handle the unknown without confusion was powerful. Algebra did not demand belief. It earned trust by consistency. Across the Islamic world, this word-based algebra became part of education. Students learned not just how to calculate, but how to reason step by step. Every solution was an explanation. Every conclusion had to be justified. This mattered deeply in a culture where law and justice relied on clear reasoning. When property had to be divided, when debts had to be settled, when contracts had to be honored, there was no room for guesswork. Algebra became a tool for fairness, but something else was happening at the same time. Scholars were beginning to notice patterns. They saw that many different problems could be solved using the same reasoning. They realized that these methods did not depend on specific numbers, but on relationships. This recognition quietly expanded the scope of mathematics. Algebra was no longer just a collection of problem-solving techniques. It was becoming a language of structure. This language did not yet use symbols, but it already had grammar. Certain steps always followed others. Certain transformations preserved balance. Certain moves were always valid, regardless of context. In this sense, algebra was teaching people how to think about thinking. As centuries passed, centers of learning emerged across the Islamic world. Libraries grew. Schools flourished. Texts were copied, commented on, and improved. Algebra did not remain frozen in its earliest form. Scholars refined explanations, clarified steps, and extended methods to new kinds of problems. Yet, despite these advances, algebra remained verbal. Everything was still written in words. This was not because symbols were unknown. Other branches of mathematics used diagrams and shorthand, but algebra required clarity above all else. Words forced precision. They left little room for ambiguity. If something did not make sense, it had to be explained again. This insistence on explanation shaped how algebra was taught. Students were trained to follow reasoning carefully, not just reach answers quickly. Understanding mattered more than speed, eventually. This knowledge began to move beyond its original cultural home. Through trade, translation, and travel, algebra crossed into Europe. When European scholars first encountered these texts, they were struck by how different they were from the geometry-heavy mathematics they knew. Here was a method that solved problems without drawing shapes, a method that addressed unknowns directly, a method that worked for practical situations. At first, European scholars translated these works almost word for word. The language was preserved. The structure remained intact. Algebra entered Europe, still wearing its original form. For a long time, nothing changed. Problems were written out in full sentences. Solutions unfolded step by step. Students learned algebra as a narrative process, but slowly, subtly, pressure began to build as problems grew more complex. The words grew longer. As methods expanded, explanations became harder to follow. Teachers sought shortcuts not to reduce understanding, but to manage complexity. They began to use abbreviations. At first, these were small, shortened words, simple marks, nothing systematic. But over generations, these marks evolved. What began as helpful shorthand slowly became a new language. Letters replaced long descriptions. Signs replaced phrases. Whole sentences collapsed into compact expressions. This was a turning point. Algebra was no longer bound to words. It became symbolic. This transformation did not happen overnight. It took centuries, and it was not universally welcomed. Some feared that symbols would obscure meaning, that students would manipulate marks without understanding their logic. In many cases, they were right. Symbols made algebra faster, but also easier to misuse. The reasoning that once had to be spoken aloud could now be skipped silently. Something was gained, something was lost. Yet the symbolic form spread, because it allowed algebra to grow beyond its original limits. It made possible new discoveries, new generalizations, new connections. But beneath every symbol, the old logic still lived. The logic of restoring balance, the logic of reasoning about what is unknown, the logic of fairness and equivalence. This logic had not been created by symbols. It had been preserved by words, and even today, when students struggle with algebra, it is often because the symbols hide the story. The reasoning is compressed until it disappears. To understand algebra fully, one must sometimes go backward, not forward. One must rediscover the explanations beneath the marks. One must remember that algebra began not as notation, but as narration. And the story was never about letters. It was about relationships. As algebra took on its new symbolic form, it gained incredible power. Problems that once took pages of explanation could now be written in a single line. Patterns that were difficult to describe could be manipulated with speed and precision. Mathematics accelerated. But acceleration came with a cost. The story slowly disappeared. Where algebra had once been spoken aloud and reasoned through carefully, it now appeared as a sequence of marks that demanded fluency before understanding. Students were expected to learn the language first and discover the meaning later. For many, that discovery never came. Algebra became something to survive rather than something to understand. This shift changed how mathematics was taught. Lessons focused on procedures instead of ideas. Correct answers mattered more than explanations. The balance that once defined algebra was replaced by efficiency. Yet, the original purpose of algebra had not changed. It was still about reasoning through uncertainty. It was still about restoring fairness. It was still about making sense of what it was missing. Only now, those ideas were hidden beneath layers of notation. This hiding of meaning created fear. Many learners began to believe algebra was mysterious, even hostile. They saw symbols as barriers rather than tools. The very abstraction that made algebra powerful also made it distant. But abstraction was never meant to replace understanding. It was meant to protect it, in its earliest form. Algebra insisted on clarity. Every step had to be justified. Every move had to make sense. Nothing could be done simply because it worked. It had to be explained. That discipline shaped generations of thinkers, even as symbols took over. The deepest mathematicians never abandoned the story beneath them. They understood that symbols were compressed explanations, not replacements for reasoning. When they encountered a new problem, they often returned to words in their own minds. They told themselves the story of the problem before translating it into notation. This habit separated mastery from ization. The fear of algebra today is not a failure of learners. It is a failure of storytelling. When students are shown only symbols without meaning, algebra feels arbitrary. When they are taught procedures without purpose, algebra feels mechanical. But when algebra is returned to its roots, something changes. Unknowns become questions rather than threats. Balance becomes fairness rather than manipulation. Solutions become conclusions rather than tricks. Algebra begins to feel human again. Across history, the most influential mathematical advances were not driven by symbols alone. They were driven by ideas explained clearly enough to be shared, challenged, and improved. The Islamic scholars who shaped early algebra understood this deeply. Their mathematics was written for people, not for machines. It was designed to be read, discussed, and applied. They believed knowledge had a responsibility. It had to serve understanding. That belief shaped how algebra entered the world, even today. Whenever algebra is explained patiently, whenever reasoning is spoken aloud, whenever a student is encouraged to explain rather than compute, that original spirit returns. The story reemerges, and suddenly, algebra feels less like a wall and more like a bridge between what we know and what we seek, a bridge between confusion and clarity, a bridge between words and ideas. Algebra did not begin as an obstacle. It began as a solution, and perhaps the future of algebra lies not in inventing new symbols, but in remembering why the old words mattered. By the time algebra had fully entered the modern world, it no longer belonged to any single civilization. It had crossed languages, religions, and borders. Its origins were rarely mentioned. Its story was often forgotten, yet algebra endured it. Endured because it addressed something universal. Every human society encounters uncertainty. Every human problem contains something unknown. Algebra offered a way to face that unknown without fear. It did not promise instant answers. It promised a path built on balance, reasoning, and patience. This is why algebra became universal. Not because it was powerful, but because it was fair. The same reasoning applied no matter who asked the question. The same logic worked. Regardless of context, algebra treated the unknown with respect. It did not guess. It did not assume. It reasoned. As mathematics advanced, algebra became the language of science, engineering, economics, and technology. It shaped how humans model the world. It allowed predictions, designs, and systems to be built before they existed. But even in its most advanced forms, algebra still rests on the same foundation laid centuries ago. A foundation built without symbols. a foundation built with words, explanations, and logic. When modern learners struggle with algebra, they are often struggling not with mathematics, but with compression. Too much meaning has been packed into too little space. The story has been folded so tightly that it disappears. To unfold it again is not to go backward. It is to return to clarity. When a learner explains a problem aloud, they are practicing the oldest form of algebra. When they justify each step, they are restoring the balance that defined its birth. When they treat the unknown as something to understand rather than fear, they are standing in a tradition older than symbols. Algebra is not cold. It is careful. It is not abstract in order to confuse it. It is abstract in order to include every possible case. This is its quiet strength. The Islamic scholars who shaped Islam shaped algebra understood that knowledge must be teachable to be useful. They wrote for humans, not for experts alone. They believed that understanding was more important than speed, an explanation more valuable than shortcuts. That belief still matters. In a world driven by efficiency, Algebra reminds us that some things cannot be rushed. Reasoning takes time. Understanding unfolds gradually. Balance must be maintained. Algebra teaches us how to think when certainty is absent, and that may be its greatest gift. Long after the names of its founders faded from memory, algebra continued to shape how humans approach problems. It became the invisible structure beneath science, finance, and technology. It became so familiar that it seemed inevitable. But it was not inevitable. It was created by people who believed that words could reason, that logic could be taught, and that the unknown could be approached calmly. Algebra was born as a story about restoring what is missing, a story about balancing what is unequal, a story about reasoning with care, and perhaps the future of algebra depends on whether we choose to tell that story again. If we do, algebra becomes less frightening and more meaningful. It becomes a language of understanding rather than intimidation. It becomes what it was always meant to be, a bridge between knowing and not knowing, and that bridge was built not with symbols, but with words.